Good morning, everyone, and thank you for being here. My name is Majid Zuraikat, and I will be talking about applied ergonomics, advanced in technology to assess risk factors. First of all, I would like to thank Pennsylvania OSHA Consultation Office for having me today. Please, any questions you have, you can submit in the chat. We will try to answer them after we're done with the presentation. If for any reason we have technical issues with the questions and the chat session, we are going to answer the question 7 days after the webinar. A little bit about myself. I have a PhD with a minor in applied statistics from West Virginia University, WVU, in 2014. I have a master's in safety sciences from IUP in 2008. My background is in chemical engineering and process safety. I have 10 years experience as a process and chemical engineer. I have been with IUP since 2013. This is my 11th year, and I am the current PhD program coordinator. My area of research is ergonomic and human factor. Let's start talking about ergonomics. Ergonomics, based on the International Ergonomic Association, is a multidisciplinary field that applies psychological and physiological principles to design product, process, and systems that are safe, comfortable, and effective for human to use. In a simple word, is to design the workplace to fit the human or the operator, the worker. Ergonomics has three subsets or divisions. One is the cognitive ergonomic, which is focused on human factors, their mental capabilities, psychological factors. It also has the physical ergonomics, which is focused on the interaction between human and machine. And then the organizational ergonomics, which is focused on the organizational factor, the environment, the psychosocial factor, organizational safety culture, etc., and their impact on worker safety. Just to show you a systematic view of ergonomics and what it does for the workplace, as I told you, there's the cognitive ergonomics, as you can see there. And this is focused on the mental process, human capability of doing the job. Are they capable? And consider the human capability when we design the task for the human to do. How much is the task demand? It considers all those factors and take them into consideration. Organizational ergonomics focus on the organizational factors related to the communication, teamwork, safety culture, safety climate, leadership, participation and involvement in the process. All of those factors together, in addition to the task itself and its design, which is under physical ergonomics, they all work together, combine together to make sure that the safety of the workplace, safety of the workers, and at the same time enhance productivity and enhance workplace safety. Let's talk about musculoskeletal disorder, the major and most common injury related to ergonomics. And why it's important? Because 30% of the injury in the workplace in almost all industries is ergonomic related or musculoskeletal injuries. What MSDs? MSDs are injuries to the structure of our musculoskeletal system, which is made of three components. The active tissues, which is the muscles, the passive tissue, which is the bones, ligament, and tendons, and the nerve system, which is coordinate the job of these tissues. There's two types of MSDs. There's the acute and there's the chronic. Acute, which is happening immediately, for example, sprain strain due to sudden loads. And chronic, and that's the most common type of MSDs because in nature they are accumulative. For example, carpal tunnel syndrome, herniated disc, tendinitis, white finger, etc. Now, since MSDs are a cumulative injury. They are not easy to tie them to the workplace, or their origin to the workplace, or caused by workplace, or even to classify them as work-related injuries. And that's the reason why actually OSHA failed in the 80s for almost 20 years work on an ergonomic standards, but failed to implement that or to have it in effect. Why? Because it wasn't easy to distinguish the cause of the MSD's injury if it's work-related or it's not work-related. For example, somebody finishing their work, they go home and now start working or do some work around the house, painting, cleaning, and now they get injured. So how you can separate or distinguish that this injury is actually caused by workplace, it's not caused by any other job, like you can have another job. And that what actually a major reason for the failure of the ergonomic standards, OSHA ergonomic standards. Give you some statistics to show you the significance of the problem. Let's start with globally first. MSDs are the second leading cause of non-fatal injuries. According to the World Health Organization in 2021, there were 367 million almost incident cases and almost 1,700,000,000 prevalent cases. 50 to 70% of those incidents are work-related, and they are led by the low back pain and neck pain. Women suffer more due to the differences in the fiber muscle composition between men and women, or male and female, and older population are more susceptible to musculoskeletal disorder because with age muscle strength decreases. Just to show you some numbers from 1990 globally to 2001 and the cases and how the trend is actually on the rise. It's not going down, it's actually going up. If you look at on the left side, the top, the orange diagram or figure, you can see the number of incident cases and it's trending up. Below that, in blue, is the number of deaths, fatalities related to musculoskeletal disorder. On the top right, as you can see in red, that is the number of prevalence cases. And this is a clear evidence of how big the problem is. Let's talk about the US. In the US, these are the latest number in 2022 based on the Bureau of Labor Statistics data. There is almost 3 million total recordable cases. Most of those are traumatic injury and disorders. For days away from work that related to musculoskeletal disorder, there is almost 500,000 cases, and the incident rate is 25.3. Out of those, MSDs, traumatic injury and disorders, is responsible for 487 or 88,000 days away from work and a 24.5 incident rate. From that, injuries to the muscle, tendons, ligament, and joint is 365,000, which is 18.4 incident rate. Sprain, strain, and tears caused 342 almost cases of days away from work, which is huge numbers. More statistic in the US. Coming from Liberty Mutual, the 2024 Workplace Safety Index. These are the top 10 causes for the major cost, which is the 58 billion per year to the US. US business spend more than 1 billion per week on workplace injuries for a total of 58 billion per year. And these are the top 10 causes cost the US around 47 or 48 billion per year of a total of 82.5% of the total. That's a lot of money. Now, if you look at these top 10, you will see that overexertion involving outside source is responsible for almost 21.5% of that, which is $12.5 billion. which is number one or ranked number one at the top of the list. The number 5 is other exertions or body reactions, and it's responsible for almost $3.7 billion and 6%. Number 10 is repetitive motion involving microtasks. It's around 1.5 billion. And if a total for these 3 out of the top 10 is $17.71 billion annually. And this is a conservative estimate. And remember, there is an underreporting of those injuries. And that's the reason why it is really important to focus in ergonomic related injury. So let's focus on the risk factors, especially for physical ergonomics. Those factors are forceful exertions, awkward postures, frequency repetition, duration, other environmental factors including vibration and thermal stresses like temperature. And the focus here is going to be on, in this presentation, is going to be on the forceful exertion, measuring the force and strength, and the awkward postures. Now, we need to look at the risk factors as part of the picture. Okay, when we talk about physical risk factors, we're talking about the interaction between the human and the system, as you can see in the diagram on the left, on the right side. Now, we cannot separate those. When we study that, we have to study that within the whole context, within the whole framework, as part of the organization, as part of the environment. We cannot separate the human system interaction and study that, because there is some distraction. There is a synergistic effect between those factors, and you cannot have one and not the other. For example, when you do force, like lifting loads, moving loads, you're doing that with awkward postures. You're doing that for a specific period of time. You could be exposed to other environmental factors, noise, for example, vibration. You could have psychosocial factors, human-to-human interaction, distracted by other workers. And then the impact of the organization, we have to look at with the whole bigger picture, which is the organizational factor and management behavior. What policies you have in place, what rules, procedures. So we have to look this within the bigger picture, within this big frame, as you can see on the left, from the physical devices, the task, physical ergonomics. We talk about individual behavior, which is the human factors or cognitive capabilities. We're going to talk about the team, the interaction between a human and a human, because you cannot just operate the machine when you are like separate, unless you want to be in a specific like isolated room to be by yourself to do the job, and that's not the case in the workplace. So all these factors has to be considered. And as I said, our focus is going to be on 2 major risk factors, even though you cannot separate or focus on one without having the impact of the others. Now, these risk factors, they induce fatigue, and there's 2 types of fatigue, mental fatigue and physical fatigue. You are going to have a combination of those. Now, our spine stability is a function of a highly coordinated work or activities between 3 systems that we talked about. The active, which is the muscles, the passive, which is the bones, ligament, and tendons, with the coordination of our neural or nerve system, which is send the signal or coordinate the work between those. Now, when everything is fine, smooth, the coordination is there, your muscles is not fatigued, your passive tissues are not fatigued like the bones, your spine or skeletal muscle and muscle system, your neural system is not fatigued. Doing the tasks could generate 2 types of fatigue, either the mental fatigue, which is impacting our cognitive, or physical, which is the active and passive tissue. These risk factors will induce that 2 types of these fatigues, and then will impact the stability of our spine. Let's talk about the new technology, on the advances in the technology versus the traditional. Why you are moving to the technology or to the new advances in technology compared to the traditional method like the ruler, REBA, checklist, strain index, Nayash lifting equations, Snook tables, etc., etc., etc. Now, technology, they are more reliable and accurate. You can take a very accurate and precise readings. They are objective, not subjective like the ruler and the REBA. If you are not familiar with the ruler is the rapid upper limb assessment, and REBA is the rapid entire body assessment. Or we're using checklist, for example, or Nayash lifting equations. Those are subjective. It depends on the one who's taking the readings. For example, measuring the posture, or rank the posture or the force, etc. So it is more subjective. It's less expensive, which is the good thing about those traditional method, because technology is more expensive, but it's more reliable, it's more objective. It also provides continuous monitoring. Technology give you a continuous monitoring. You can monitor the whole 8 hours of operation. You can see trends in the data over time. These sensors are small, and they usually stick on the body either by medical double tape or by Velcro, or they can be insert like insole in your shoes. Now, when we talk about ruler REBA, those traditional methods, they are tedious. They take a long time to do, in addition to being subjective. They are time consuming. And the other negative about them, they take a screenshot or a snapshot. They evaluate a specific point of time. For example, when I want to evaluate a task using ruler or REBA, the posture, we take a screenshot, assuming that is going to be, this is the worst case scenario, and then we evaluate that shot. To be able to evaluate the whole task, that means I have to take photos of every instant or single second of this task to we have a continuous reading, which is time consuming. And to complete, for example, as you can see there, that is the ruler checklist. To do it, it is really confusing sometimes, and it's not easy to follow. And it's give you a number, subjective number, indicating and provide some recommendation based on that number. However, the technology is going to give you specific readings. It can measure muscle activity, posture in a 3-dimension X and Y and Z. It will give you twisting, flexion, extension, rotation, bending in all direction and different and all types of movement, which is not the case in those traditional methods. This is just to give you a bigger picture of the ruler checklist. As you can see, to follow, it's not easy. Let's talk about the force and how we measure our force or exertions, which is there is no task without force. You cannot do any task or complete any task without exerting a force required. The bigger the load, the more the forces we exert. What is EMG or electromyography? It's the study of muscle function through the inquiry of the electrical signal the muscle emanate or induce. Now, what happened? A signal from the brain, motor neuron, are sent either by frequency or by intensity. The more the task is, intensive the task is, the more the neuron frequency or intensity is going to the muscle fiber, which is trigger the muscle to contract and produce the force that we need to do. As you can see there, if we flex our muscles, we produce activity, we produce the force needed to do the job. Now, how we control these contractions or the muscle activity is by the number, the frequency of the motor neurons that come into the muscle fiber, or by their intensity. So it depends on the job that has been done. Now, what we measure it as voltage and frequency. Since it's an electrical signal, we use sensors like you can see in the picture there. They are very small sensors that you use, and they are made of 99% silver, and they stick on your muscle using medical double T. They have no impact. The voltage is very low. They have no risk associated with them. We have this system and we have been using it for a long period of time now to conduct research. Let's illustrate and show you an example for this. As you can see, this person is doing muscle. As you can see on the top there, as you can see there, the muscle is firing. We're measuring that in volt, amplitude of the muscle activity. With time, we're gonna still start getting fatigued. So we can measure, so muscle activity can be an indicator of muscle fatigue. The lower the amplitude, the more fatigued we are. Another thing that when we measure muscle activity, we measure it as we said, voltage, and it also has a frequency. It's like any electrical system in your house, dishwasher, chainsaw. When you measure it, we measure it by voltage, which is like 110 volt, and a frequency, 50 to 60 hertz. The same thing with our muscles. Since it's an electrical signal, then we measure voltage and we can measure frequency. Usually when we do the muscle activity, we use higher frequency because we are not fatigued. When we start fatigue, what happened? We move from higher frequency to lower frequency. And the change in the median or the mean frequency can be an indicator of muscle fatigue. Let's talk about awkward posture and why it's important. Neutral posture will give us 100% of our strength to do the job. For a specific period of time, it depends on the load. Remember, those risk factors we talked about, you're not going to have one. You're going to have a combination. You cannot do a job lifting a box without using awkward posture or change your joint angles. So, to give you an idea about how awkward posture impact our strength, our exertions, look for the back first. Back is a big muscle. It has to be neutral. If you move away like more than 10 to 15 degrees, you start to get to the low stress area on the back. That means we're going to start to get fatigue faster with less time. If your back is flexed more than 30 degrees, that's when we have a higher stress on our back. We're going to get fatigued faster. The same thing with the neck. The neck is a smaller muscle than the back, meaning the neutral posture is up to 5 to 10 degrees. I prefer 5. Up to 10 degrees is okay. When we start getting more than 10 degrees, we get to the low stress on our neck to do the job. More than 20 degrees is a high stress and we start to get fatigued fast. Our wrist, straight wrist, will give us a 100% of our strength to do like a gripping, grip force. If you halfway bend your wrist halfway, that will reduce your strength to 65 to 75%, almost 30% reduction in your strength, gripping force reduced. If you have fully bent wrist this way, you reduce it almost to 15 to 20%. You lose 80% of your strength to do the job. When we do lifting with postures, usually, as you all know, we lift. To lift, we have to have the load as close to our body as possible to reduce the moment. The way your hands away with the load, you are increasing the distance and you're increasing the moment. Moment is a function of the force multiplied by distance, the perpendicular distance from the center of the mass. So the more the weight is away, the more the force that pull you down. And that's the reason if you do hold the weight in your hands for a few seconds, you get tired faster when you are holding it very close to your body, because we're producing, in this case, there's more moment generated by that force on our body that we have to resist. So we need to keep it within the green box, with a neutral posture. overextending in the front or the top, we get fatigued faster. And the load that we can do or carry will be reduced almost by 50%, if not even more. As you can see, we don't want to get to the danger zone. And that's when people doing like drilling above the head, above the shoulder head, we get fatigued faster because we're doing awkward posture. And our hand is extended. That means there's a lot of moment on our body, in our wrist, in our muscles. This is one of the motion tracking system that we have we have the Extens system. It doesn't matter what system. There's a lot of technology there that measure the posture, your joint angles in 3 dimensions, or axes X, Y, and Z. They are very small. We stick them using Velcros over the joint in your body. For example, if I want to measure the wrist, we have to have a sensor around that joint. The same thing with the hand. The same thing, we need one for the head and 2 on the shoulders, 1 in the sternum. So we cover all the joints in our body using those small sensors. They have no impact, there's no minimum voltage actually associated with them other than the frequency for the wireless signal. They are wireless, very small sizes, as you can see in those pictures. And they are real-time motion tracking system in 3 axes or 3 dimensions. And you can see live presentations of what you are doing immediately on your computer, the software associated with that technology. As you can see in those pictures down there, when you do like wire manipulation, the task from the left, so wire manipulation, you can see the simulation of your body doing, and it will measure all the angles of your body. Screwing, standing or sitting, or when you do high reach, overhead reaching, load manipulation like twisting, standing or sitting. To illustrate how the motion tracking system sensors are placed on the subject body, here is a video that we created from one of our research studies with our undergraduate as research assistant. The purpose of the study was to evaluate 5 different surfaces in the construction industry: mud, plywood, steel decking, gravel, and concrete, and to see how or evaluate how people adjust their gait and posture to avoid slip, trip, falls on different surfaces. Let's watch. So these are the sensors placed on the subjects. These are very small sensors, as I told you, and they are strapped around with Velcro. We have to place a sensor on every joint, like the pelvis, the foot, the upper and lower legs or feet, the upper and lower arm, the hand itself, the sternum, the 2 shoulders, the head. So every joint has to be motion. There should be a sensor on every joint to be able to capture the whole body. If you want the upper body, you can only focus on the upper body sensors. If you want the lower body, you can do the same thing. It depends on what task you are evaluating, or you can do the whole body, as you can see in this research. Now the subject is moving with the sensors on them on different surfaces. This is the gravel one. Now they are doing with load. So we did it with and without load. And this is the software, as you can see, the motion tracking live while the people or the subjects are doing the task. In this slide, we can see on the right a figure demonstrating the data collection. You can see the subject is wearing all the sensors. And on right of that, you can see the simulation of the subject in real time. Below that, that's where we extract the data as a graph. for the flexion extension, bending, twisting, rotation angles. You can select any joint from the drop menu there behind the subject, as you can see, and you can select any joint that you want to see these angles for in the XYZ dimensions or axes. On the right, we have a video from the company, and we can watch it together, showing a demonstration of the data collection. But please be careful when you're going to see the video right now. You're going to see the actual subject and the simulation or the virtual reality of that subject in real time. That's not the case. Those simulations are embedded in the video just to show you how it's done. The simulation should be shown on your software in the computer. So let's watch together. As you can see, that's what I'm talking about, the simulation. So those simulations are not going to be in this video, but it's realistic. It mimics the human movement. And to do that, actually, we have to collect the anthropometric data of the subject and enter it into the software. So we have the exact dimensions of the subject. The system can give you so many things in addition to the angles. It can give you acceleration, angular velocity, center of the mass, gait parameters sometimes. So it has a lot of features. This is a simulation of the, as you can see, the car. This is for athletic as well. So it can be used in many field and research areas. Another system using the AI, artificial intelligence technology, is Tumiki, and there's a lot of those advances in technology using the AI to monitor or evaluate workplace safety using apps. One of the apps is the Tumiki one. That's the one you can see in this picture. It's a camera-based assessment. You download the app, you take a video of the tasks, and it's going to show you the joint green coloring with red coloring, indicating if it's a red, that means an awkward posture, it's danger zone, and if it's a green, that means it is in neutral or close to the neutral position that you need to. And then it conducts a risk assessment and create an output indicating how much risk, if it's a high risk, low risk, and what can be done to this task. It's like a build a tree model of a human activity from a 2D video. It's very simple, it's very easy, it's not time consuming. You just take the video, you upload the video to the app, and immediately it generate the simulation for the task while it's being done, and generate a immediate report for you to indicating the risk for this task. It's very convenient. There's a lot of others similar software that do similar job. This is another example to show you to do like in the healthcare, patient positioning, custodial work, and it gives you the task if it's how much is the MSD risk, 50%, 10%, 0, and what can be improving, what postures or joint angles are at risk, high risk. Other system that we can use, one of them is about the posture called upright go-to. It's a very simple sensor. You positioned it on almost under around the C7 in your neck, and you download the app. You wear it, you start working. If your posture is in neutral, it's going to be green. Whenever your posture starts to deviate from the neutral posture, it's going to change the red and warn you, give you an instant feedback that your posture is not neutral and you have to change it. However, it doesn't give you readings or does not quantify the posture, but it gives you an indication and a warning and immediate readings. It's a very simple, easy system. They're not very expensive. There's multiple, as I said, this is one example of those systems. There's other systems in soil, the gate. We limited this presentation for only two systems, which is the forces, which is the EMG, and the posture or joint angles. Maybe for the future we can go with other system, hopefully in the future. Well, thank you all, and if you have any questions, please let me know or ask them, and we'll be more than happy to answer them for you. Thank you.